Hello everyone, welcome back to Sai Homeschool. Please like, share, and subscribe my channel. So last class in metals and non-metals, we discussed physical properties and in chemical properties. One of the most important reaction, that is reaction of metals with oxygen, we discussed. Today we will discuss reaction of metals with water. So what will happen when metal reacts with the water? In these few metals, it will be react with the cold water. Few metals it will be react with hot water. Few metals which will not react even at a cold water and also at hot water. Those metals we will see. So those few metals which will be react with only with the few metals which will be react with steam, not with the hot water and cold water. That is, so here if you observe this experiment, action of steam on a metal. That is, so here you have to take a glass wool soaked in a water. You have to start burning. So in the test tube, you have to close this. So here you have to take a metal sample, that is iron or maybe aluminium. You can take iron, that is, so we will see which metals which will not react with even with the hot water and cold water. Here metal sample, that is iron, you have to take. You start burning. So you will get a evaporation of water in this pool. So here you will get a water vapor, means steam. So to this steam, this metal it will be reacts. Here delivery tube you have to take. That delivery tube you have to put it into the soap water solution, and one inverted test tube you should keep into that soap water solution. So here what will happen? So when it start getting react with this steam, so you will get a hydrogen gas, evaporation of hydrogen gas, you will get it here. So here if you observe, when to the inverted test tube, you will get hydrogen gas collected here. Or else if you remove that, the bubbles it will come out. For that first chapter we studied, no? So if we, for this hydrogen bubbles, if you touch with the candle, burning candle, you will get a pop sound. Then you can identify there is a hydrogen gas, it will be present. So here, one, it is metals react with the water, you will get a metal oxide and hydrogen gas. That is here, liberation of hydrogen gas, it will be takes place. This metal oxides, it is soluble in water. This metal oxide, again, it will be soluble in water. You will get metal hydroxide. That is what all the metals which will not react with water, that above experiment we saw. So metal, it will be reacted with the steam. So metals that are potassium and sodium, if you take that, we know that even in a cold water also, the reaction of this potassium and sodium will be vigorously. Last class we studied. That's why we will store potassium and sodium in a kerosene to avoid this violent reaction along with the air or maybe water. So the reaction it will be violent. That is also exothermic. Here evolved hydrogen gas immediately catches the fire. So if you take a potassium and sodium, when it will be react with the cold water, even it will be react with cold water, you will get potassium hydroxide, hydrogen gas, and lot of heat will be liberated. So that reaction of potassium and sodium in cold water, that is also called as a exothermic reaction. So calcium with less violent. So calcium also reacts with the cold water. It will be not how the potassium and sodium reacts vigorously, violently. It is not that much violently. It is less violent and it will produce the heat. It is not sufficient for hydrogen to catch the fire. So that is why here sodium and potassium is more reactive. Calcium is less reactive with the cold water. So calcium starts flowing because bubbles of hydrogen gas is formed stick to the surface of the metal. So if you take a calcium, that calcium will get floats on the water, then hydrogen gas will be sticking to the surface of the metal. So we studied how the metals react with steam and cold water. Now, and also metals react with the hot water. So few metals which will not react with the cold water. That is one example we can take a magnesium. Magnesium does not react with cold water. So magnesium reacts with hot water. So you will get a magnesium hydroxide and hydrogen gas. So here if you take, you can take example when magnesium reacts with the water. That is here we are taking a, what we are taking here? It is hot water. It will not react with the cold water. You will get a magnesium hydroxide. You will get here it is soluble in water and you will get a magnesium hydroxide plus hydrogen gas. So metals like aluminum, iron, it will do not react with cold water and also hot water. Above experiment that is we saw here we took is iron or maybe aluminium. So if you take aluminium or iron in the presence of steam, so steam is also a form of water. That is you will get a Al2O3 and hydrogen gas will be liberated. Above experiment we saw that in the soap solution how the hydrogen gas will be liberated. So you will get Fe3O4. That is, so metals such as lead, copper, silver, gold do not react with water at all. So we already last class we studied. That is, few metals have more reactive, few metals are less reactive, few metals which will not react with the air and water. That is lead, copper, silver and gold. So that silver and gold ornaments we can use for our daily use. That is what we are using silver and gold. It will not react easily. So it is used to make a ornament. What happens when metals reacts with the acids? So now we've studied how metal reacts with hot water, how metals react with cold water, how metals reacts, few metals reacts with steam. Now how these metals reacts with acids. So we already chemical reactions and equations studied. When acids reacts with the metal, what will happen? You will get salt and hydrogen gas. So this is the general formula already we know in the last chapter, first chapter, that is when acids reacts with the metal, you will get a salt and hydrogen. So few metals you can take magnesium, aluminum, zinc, iron with dilute hydrochloric acid. You will get a respective salts plus hydrogen gas. So this, so that is when it will be reacts with HCl, hydrochloric acid. So hydrogen gas is not evolved when, so we studied above here is when metal reacts with the acid. So we have so many acids, no? So but here these metals will be react with only hydrochloric acid. So if you take a acid, nitric acid, what will happen? Whether the metals will be react with this or not. That is nitric acid if you take, so the metal will not get evolved hydrogen gas in this nitric acid because it is a strong oxidizing agent. It oxidizes the hydrogen gas produced to water and itself get reduced to nitrogen oxide. So it will not allow these HNO3 to liberate hydrogen gas. What will happen? It is an oxidizing agent so that it will get oxidized with hydrogen gas and it forms a oxides. That is, that is why it will not react with, sorry, while reacting with the metals, it will not liberate a hydrogen gas. So magnesium, very it will be, but magnesium and manganese react with a very dilute nitric acid to evolve H2 gas. So most of the times it will not liberate hydrogen gas. So here, based on the reactivity, decreasing order of the reactivity, we can see. So no bubbles were seen in that scene, and temperature also remained unchanged. So if you observe the some methods, so how the reactions will be takes place based on the whether it will be violently the reaction takes place or less violently it will be taking place based on the products we are getting, how much heat we are that is liberating, like that. So how metals reacts with the salt solution. So metals reacts with the salt solution. We already know that this is displacement reaction. So these reactions we can also call it as a displacement reaction. Salt solution means here copper sulfate solution we have to take. We have to dip iron nail into this. What will happen? Iron will replace as a copper. Then it will be changed into colorless. That is, so if you take a iron, so metal reacts with a salt solution, you will get salt solution of A. Here means here we take a iron. So first chapter we studied displacement reaction. That is more reactive element displaces less reactive element. Here iron displaces a copper. So when we take a copper sulfate solution, so in that copper sulfate solution we have to dip iron nail. This iron is more reactive than copper, so that it will displaces a copper and you will get a copper iron sulfate solution and copper will be separate. That is the this. So when metals reacts with salt solution, you will get metal and respective salt solution. That is displacement reaction. If you go to the chemical reaction and equation, you can understand this easily along with the examples. When here I took iron nail dipped in a copper sulfate solution, we will get a iron sulfate solution. So it is here just they give one example what we are taking a metal A respective solution, we will get it here. One more we can take here is copper. Copper when reacts with the AgNO3, he will get a copper nitrate plus silver will be separates out. Then if you coming to the reactivity series, based on the displacement reactions, it will be takes place with the reactivity. So reactivity series list of the metals arranged in their decreasing order of their reactivity. So how it will be displaces one element with the another. So above we studied displacement reaction, more reactive elements is displacing less reactive elements. If you see potassium, sodium, calcium and magnesium are most reactive. This aluminum, zinc, iron, lead are reactivity decreases means it is moderate. Then if you come to last three, these will be very less reactive. So if you observe the reactive, this is very important. You have to learn which is more reactive than which element. Then only you can write the displacement reactions, whether it can be displaces or not. That is reactivity series. What is meant by reactivity series is a list of metals arranged in the decreasing order of their activity. Reactivity, that is called reactivity series. Next it is how do metals and non-metal reacts with each other. So before going to this topic, you should know the electronic configuration. So why means here electronic configuration you should understand is here if you take a metal, when metal reacts with the what here non-metal. So when metal reacts with the non-metal, so here if you take, so chemical reactions here what is happening, that is by giving and taking of a elements. So here if you take metals will be give or donate electrons. It will, metals will always, it has the capacity to donate electrons. It will give electrons. So non-metals, it is always, it will take a electrons. Gaining of electrons, it will take electrons. So before going to this reaction of metals and non-metals, how do they react? You should know the electronic configuration. So already we studied in a ninth standard. You all are familiar with the electronic configuration. We already know that. So I'll just write at the center there is a nucleus atom. It will be present. So around this there is a shells. It will be present. Right. So this already you studied in the ninth standard and eighth standard how atomic orbitals will be arranged. That is, there is a shells around the nucleus, electrons revolving around the nucleus with each shell. So if you take this, we can name it as a first shell. It will be K shell. First shell we can call it as a K shell. Second it is L shell. Then it is M and N. This you should remember that. So electrons revolving around the nucleus. So the address of these electrons we will call the electronic configuration. So on which orbital the electrons will be present, that we should learn through this electronic configuration. So if you take the nucleus, around the nucleus there is a orbitals or shells, it will be present. These we also call it as shells or maybe orbitals. Sorry, shells or maybe orbitals we can call it. So these shells, so if you know the number of electrons present in each cell, then you can know the electronic configuration and try to write the electronic configuration. So in a K shell, so all these shells have again subshells. Subshells, K shell having, yes, it is subshell, it is yes. Then L shell having S and P. M shell having S, P and D. This N shell having S, P, D and F. So we can observe here S orbital having how many electrons in the first shell is 2. Here 2 subshells we have, that is S and P. This we have S shell we have already 2. P we have 6 electrons. So if you take a D shell, 2 we have electrons at S, 6 at P. Then D shell having 10 electrons and F shell having 14 electrons. So you should write the general electronic configuration to learn to write the electronic configuration based on the atomic number. That is, so electronic configuration generally you should know. Here it is a first shell. Sorry, first shell it is S orbital having how many electrons? 2 electrons. Second shell having first subshells is 2s and 2p. 2p. S orbital we already know it is having 2 electrons. Number of electrons we'll write above here. So p orbital having 6, sorry, subshell having 6 electrons like that. 3 s. Third orbital it is having how many subshells? 3. That is S, P and D. S having how many electrons? 2 electrons. S having 2 electrons. P having 6 electrons. D having 10 electrons. This is general electronic configuration that you should remember. Fourth shell having how many subshells? S, P, and D. Along with that, we have fourth shell having subshell. It is a 4F. It is. So that we know that remaining everything it is same. F orbital having how many electrons? 14 electrons. This is having 14 electrons. We already know S orbital having 2. P orbital having 6 electrons. D orbital having 10 electrons and F orbital having 14 electrons. Based on that, how to write the electronic configuration for few elements. So if you take a helium, what is the term for atomic number? You have to equalize the number of electrons. That is what we said. So here if we take a element helium, atomic number of helium is 2. So if you observe the electronic configuration, 2 electrons where it will be present. So if you observe here, so 1s2. So you have to write a K shell, it is having 1s2. That is neon atomic number is 10. Here you can write 1s2, 2s2, 2p6. Electronic configuration how we will write is for this 1s, 2 electrons in K means S orbital. So here 2 electrons. Here 10 you have to equalize with the number of electrons, that is 1s2, 2s2. For 10 we are writing 2s2. Remaining how many we have? We can write 2p6. If we write 2p6 here, it will become a 2 plus 2, 4. 4 plus 6 is 10. So here total number of electrons in a first is 2. Here K shell is 2. L shell having 2 subshells. In that how many electrons we have? 8 electrons. 6 plus 2, 8 electrons. So if you write electronic configuration like that for all these elements, you will get a number of electrons present in each shell. That is, it will complete the active structure. Means so outermost electrons what we have present in the electronic configuration, that should be fulfilled. It should be 8. So if you take metals reacts with the non-metals, that is what we said. So electronic configuration, if you write for a sodium, you will get 1s2, 2s2, 2p6 and 6. So number, you should know the atomic number is 11 for sodium. If you write electronic configuration, you will get 1s2, 2s2, 2p6, 6 it is 10, then 1 remaining it is 3s1 you will get. So here valency electrons is how much? 1 it is for sodium. If you write electronic configuration for chlorine, here you will write as it is 1s2, 2s2 and 2p6 it will be. Then if you come to the 3s orbital, so what will happen? To write 7 electron, 3s2, 3p6, 6, 7 it will be, right? So 11 you should, 8. So chlorine atomic number you should know first, that is 17. So if you take 1s2 and 2s2, 8 plus 2, 10. Remaining we should write 7, that is 2 plus 5, 2p 5. That is here outermost electrons present in third orbital will be 7. It is so here now how can you understand that whether it is a giving which atom is taking electrons and which is giving a electron. If you observe the sodium here, it has only one electron, valency electron. Here how many? One valency. It has 7 outermost electrons present around the chlorine. So it has only one electron present. So which is more capacity to, so 7 electrons has the capacity to accept one electron. One electron is can gain the 7 electrons. So it is more energy to gain the electron. That is why here only one electron, it is weak, so that it cannot able to gain the 7 electrons. If it donate one electron, it is also fulfilled. Then chlorine also get fulfilled. So that what will happen? One electron here it is also want to become active structure. It has one electron less. So 7 electrons are going to gain one electron easily, so that so one electron comes here. See here, if you observe. So these going to get friends, and Na plus and Cl minus. Na plus means it here going to, it is donate electron. It is positive. It is gaining electron. It is negative. So that Na plus Cl minus. So it is only one electron it is going to donate. It is gaining one electrons. That is what metals and non-metals. These chemical reactions is nothing but giving and taking of electrons to become. So here they are getting friends and to become a one atom, that is NaCl. So here what is happening when sodium and chlorine ions being oppositely charged held by a strong electronic force of attraction will be exist in the sodium chloride. So when they are having positive and negative ions, it will be present. Force of attraction will be more in this by donating and gaining a electrons. Means force of attraction means very more friendship they are having. Easily they can get friends by donating and accepting electrons. That is, this example you should observe how many, write the electronic configuration for magnesium. How many electrons you will get it. So if you write chlorine, already we know 7 electrons. So what will happen here? Magnesium has 2 valency electrons. So if you write a chlorine need only 1 electron to fulfill. So here what happened is, it is going to give for 2 chlorine atoms. It has 2 electrons, one will give to chlorine. So chlorine, that enough for the chlorine. It won't take another. If it is having extra, if it takes means again it will be unfilled. So that to fulfill it need only 1 electron. So it will absorb one, it will take 1 electron from a magnesium. And what will do is this, it will be another chlorine will be, magnesium will give one more electron to the another chlorine, so that it has the capacity to donate 2 electrons. Mg2 plus Cl has 2 chlorine atoms are gaining a electron. So this chlorine atom gaining 1 electron, another chlorine atom gaining 1 electron, so that these two chlorine atoms is going to get MgCl2. That is what on a valency electrons. It will be how many electrons it can transfer and how many number of electrons which can accept. Here it is 1, here it is 1. So these compounds formed by transfer of electrons from metals to the non-metals is known as ionic compounds or electrovalent compounds. So this is very important. They will ask how the force of attraction between the MgCl you should show along with the electronic configuration. So you should write the electronic configuration, magnesium and chlorine. Write the valency electrons present, that is outermost electrons present, that you should write. Then which is the capacity to donate electron, which has the capacity to accept electron. Where there is a more number of elements present in the outermost shell, that has the capacity to absorb less amount. So we already know if we are energetic, we can get from weak persons like that. So here 2 electrons only means it cannot gain 7 electrons or 6 electrons from this. So that it will give a 1 electron easily and it will gain 1 electron. That is what electronic configuration. We'll see next these properties of ionic compounds, what we studied. Covalent compounds are ionic compounds by using this electronic configuration. Thank you for watching. Please subscribe my channel.